Good evening, everyone, and welcome to Robotic Explorers in Space with Mike Frost, astronomer and engineer. My name's Stephen Powley, and I'm a volunteer with the IET Derbyshire and Nottinghamshire local network in the United Kingdom. I'm also the founder of an event series called Robot Day, of which tonight's webinar forms a part. Robot Day aims to inspire people of all ages in science, technology, engineering, arts, and mathematics, with a focus on robotics, automation, and artificial intelligence. In Derbyshire, we deliver the events in partnership with Quad, who are a digital arts venue in Derby. So our speaker tonight is Mike Frost. Mike Frost is a systems engineer in his day job, and he works at GE Power Conversion in Rugby in the UK Midlands. He specialises in the automation of steel rolling mills around the world. And more importantly for this evening, Mike is an amateur astronomer, a fellow of the Royal Astronomical Society, no less, and director of the British Astronomical Association's historical section. Mike is also a STEM ambassador and gives talks to astronomy societies, schools, and anyone else who'll listen. So if you enjoy what you see tonight and you're a member of a society or a group, do feel free to get in touch with Mike through his personal website, and you can see the links there with the QR codes, and also a link to Mike's page where he tells you more about his role as director of the BAA history section. So without further ado, it's time to welcome Mike to the stream. Hello, Mike.
Hello there, Stephen. I'm unmuted. Yes, you can hear me. Good.
Okay, great. So I'm going to stop sharing my slides, and we'll go over to you to start the talk. Take it away.
Okay. And you should be able to see my first slide there.
We can indeed.
Okay, good stuff. Well, hello everybody. What a pleasure to talk to you all this evening. As Stephen said, thank you for the introduction, Stephen. I did note that the original slide when we first logged in said that today was 27th of October 2223, 201 years in the future. So we're off to a good start. The robots have indeed taken over, and I'm sending a message for from the future to you. Again, as the brief introduction said, I have a sort of dual career. One job paid and one job not quite so paid is that I work for GE Power Conversion in Rugby. I did mathematics and at university, and then astronomy, and I was considering doing a career in astronomy, but I had a look around and decided that perhaps engineering would be a good choice as well. And I joined it was called GC Electrical Projects in the first place in Rugby, and I'm still there 37 years later, so I must have made a good choice one way or another. And I've done quite a few bits of work for well, they've changed their name every so often, GE, and then Sedgwick, and then Alstom, and then Converteam, and now we're at GE Power Conversion, about to become GE Vernova. And most of that time I've been working in the steel industry, which takes me to steel rolling mills. I've worked on every continent except Antarctica, where there are no steel rolling mills. So I've seen quite a lot of the world that way. But in parallel with that is my career. I've kept up my interests in astronomy. I do go and see astronomical events. For example, I also travel around the world to see eclipses of the sun. And yes, I did go out to sneak out of work yesterday, Tuesday morning, to go and see the partial eclipse of the sun, which was visible from England. Not very much of the sun covered, but we did at least have some sunny weather. And I go to see total eclipses wherever they may be in the world. Had it been a total eclipse on Tuesday, I would be wherever that total eclipse was. 2 years ago, December 2020, I was the guest astronomer on the group who went to Patagonia to see the eclipse of the sun that covered that part of the world right in the middle of the pandemic. We were the first foreigners into Argentina in several months. Next year in April, I shall be in Western Australia, I hope, for the next eclipse of the sun. So I do observation, but actually I'm more interested in the history of astronomy these days, and I run the BAA's historical section, and I also I'm a member of the Society for the History of Astronomy. So I am interested in the history of the subject, and hopefully you'll see some of that tonight. Robotic explorers in space. I give a lot of talks, and some of them are in connection with the IET. In particular, I work with a chap called Derek Willer, who I'm sure many of you will be familiar with. He does a lot of outreach and schools work and so on for the IET in the Midlands. And as part of that, he also does a Robot Day presentation in centre of Coventry, not very far from where I live in Rugby. And 4 years ago, he asked if I could give a presentation for that, and I was unable to do. So he asked me again a year later, and I was hoping to do so, but unfortunately, along came the pandemic, and I was not able to give a talk about robotic explorers in space. And then the year afterwards, there was still a pandemic, so I wasn't able to give it. So I was hoping to give the talk this year, and unfortunately, this time around, the Robot Day presentation unfortunately hit some problems and couldn't happen. So this is actually the world premiere of the talk. It was originally aimed at 10-year-olds, but I've tried to spruce it up a little bit. But actually, 10-year-olds ask great questions, so I'm hoping you'll live up to what they can do. But Derek is a tremendous character, and I'm really hoping that we will have another Robot Day next year, at which maybe I'll give this talk, or maybe one of the other ones. I'm going to start by talking about robots in popular culture, and then we'll see how it compares with how they're what they actually do when we manage to put them up into space. So let's start with sci-fi robots. And as a historian, I'm going to go right back to the beginning. Where did it all start? And it started with this chap. His name is Karel Čapek, and he's Czech. Doesn't look very happy, does he? But he was a playwright, writer and playwright, in 1890, and he died just before the Second World War. In fact, he was in the Czech Republic at the time, even as the Nazis were invading. He was nominated for the Nobel Prize for Literature 7 times, so he was a very serious writer, and he's basically these days known for just one work. There are a couple of others may come up, but the work he's most known for is this one, Rossum's Universal Robots, which was a play that he wrote and premiered in the year 1920. Well, Mr. Rossum is an industrialist with his own desert island on which he has a factory, and he makes the workers there. And the Czech word for a worker is a robot. That's where it comes from. It's from the Czech language, and so he builds these humanoids. He's discovered the secret of life, and he builds these workers to do the job that other people don't want to do. But as is the nature of these things in science fiction, he gets off to an early start. That the robots eventually take over and kill off all of humanity. I'm sorry, spoiler alert if you don't know what happens in the play. And so this is what started it all off. That the robot is actually a word from the Czech language. But to me, that's not the interesting word that's there. The interesting word in Rossum's Universal Robots is the one in the middle, universal. That his idea was that somehow or other somebody would be able to build sentient beings that could do any job, as opposed to robot. In his original in the original text, it kind of implies that the robots are the workers, us, the people who do the jobs, and all we can do is very sort of minimal jobs, do the job that we're supposed to do, whereas his androids, so as they're probably better described, can do anything. And I think that's something you see throughout the history of robots in popular culture, is that they are universal workers. And perhaps that's to do with the fact that this is the age of automation. This is the age of Henry Ford and so on in America, where people were expected to do less and less repetitively, that they had one job to do, and you put the wheel on the car and then you put the wheel on the next car and so on, and so we were being, as a species, we're being reduced to being robots, to being workers who did the job that we were paid to do. Whereas if you could manufacture something that could do any job, then obviously that would be of great use industrially and economically, and that's the theme that we see. And I'm sure you know, I'm going to show you some of my favorite science fiction movies, and in all of them, they are universal robots. They are not the robots that do just the one job. They are robots that do pretty much anything. And even when they've got a specific task, they need a whole load of other skills to be able to perform it. The other thing about science fiction, I mean, when I was a kid, I used to read nothing but science fiction and grudgingly moved on to the rest of literature. The thing about science fiction is you come to realize that it reflects just as much the age of when it's written as the age in which it's purportedly set. So, for example, this is one of my favorite movies from the early years of movie science fiction, The Day the Earth Stood Still, 1951, and the robot there, Gort, this implacable, silent monster that could destroy absolutely anything. And I think the theme here, what you're seeing is this is a sort of Cold War movie. It's reflecting the idea that that the other people have weapons of immense, of almost terminal capacity to destroy, and we've got to be careful what we do with them. I've got Gort and his humanoid partner Klaatu land in Central Park, isn't it? That they come. We discover in peace, but the soldiers around, being paranoid, shoot the gift that Klaatu is about to offer, and Gort destroys the tanks nearby. So you get this. First of all, we've got this idea of immense power, but at the heart of it, this idea that immense power should be used quite wisely. And indeed, the sort of theme of the movie is perhaps it's almost religious, that be careful of the power that you have, because there may be people with immensely greater power. And it turns out that Gort is one of it's a race of guardian robots who are looking after civilizations and will not let them get out of hand. So there's a kind of hopeful message there, but it's a quite stern one, is to be careful with the power that you have, because otherwise we will immensely greater power will be unleashed on you. Another of the great movies from the 1950s, again, I'm sure many of you have seen Forbidden Planet from 1956. And superficially here, the robot here is a lot more cuddly. Robbie the robot, it starts off almost as a sort of comic figure almost, but to give the movie its credit, it becomes much more of a character and much more central to the movie and central to the development of the plot, and important to what's going on there. And again, this is a movie with more depth than you might think. It's all sort of connections to Shakespeare's The Tempest, and the idea that there are civilizations that have developed much further on and got a much greater mental capacities, and if we mess with them, well, we might unleash the power of our own subconsciousness. So it's quite deep themes, which makes it all the nicer that I hope if you've seen Forbidden Planet, that you might also have seen the excellent stage musical Return to the Forbidden Planet, which has sci-fi 1960s pop music and bad Shakespeare jokes all the way through. If you've never seen it, it's really good fun to actually go and see. And I'm very proud to say it was premiered at the Belgrade Theatre in Coventry here in the Midlands. So it has travelled widely ever since, and it's really fun to see. One of the early jukebox musicals. I was going to say with The Day the Earth Stood Still, there's a more modern remake which I haven't seen, and looking through it, I wonder how much of the present day, that the 2006 remake with Keanu Reeves, Jennifer Connelly, actually reflects the more modern era of today. And perhaps if you remade it next year, it'd have a different theme to it altogether. Incidentally, if you look on the right hand side picture there, I think that is Leslie Nielsen, who ended up in Airplane and Naked Gun and all the rest of it. He was still in the serious phase of his career. Two great 1950s movies. Moving on, robots became ever more dangerous. Gort was pretty dangerous, but it held his power back for when it was actually needed. But I think most our common stereotype of the robot, it's out to get you, and it's pretty dangerous. It's not too bad if it's a Cyberman. I mean, I always think Cybermen, they're easy to outwit. Cybermen, you just walk away quite quickly because they're lousy shots. They'll never actually shoot you, and they don't move move very quickly. So that's the way that they've got over. The Daleks have got over the going upstairs problem, but the Cybermen still move very slowly. On the other hand, I really wouldn't want to have a Terminator determined to do me damage, because I think they're rather faster, rather more lethal animals. But it's this idea of the robot as an implacable, unstoppable, you can't reason with it. It just wants to go out and do what it wants to do, and you're not going to get in its way. If it wants to kill you, it's going to kill you. That's a common theme from movie science fiction, and I can understand why. It makes for a really good thriller. Written science fiction, on the other hand, went in rather more thoughtful directions. I loved reading sci-fi when I was a kid, Robert Heinlein and Arthur C. Clarke, but in particular Isaac Asimov. And Isaac Asimov, as I'm sure you know, wrote the wonderful series of stories I, Robot, in which he introduced the 3 laws of robotics. And these are rather more cerebral approach to how robots might interact with humanity. A robot, the first law of robotics, the robot may not injure a human being or through inaction allow a human being to come to harm. Then secondly, must obey the orders given to it by human beings, except where the orders would conflict with the first law. And then it must protect its own existence, as long as such protection does not conflict with the first or second laws. And as Asimov in his iRobot stories almost forensically examined the consequences of those laws. And to a sort of nerdy geek like it was quite thrilling intellectually to figure out how he would quite icily and very coolly dissect the implications of these very logically the implications of these laws. And that didn't make for particularly good science fiction movies, of course, but it had its own thrill to it. I would say that later on they came up with a zeroth law of robotics. Again, I love the idea that, just like thermodynamics, you've got a zeroth law of robotics as well. A robot may not injure humanity, or by inaction allow humanity to come to harm. It's a bigger law still. And not least amongst the 3 laws of robotics is it did introduce the word robotics into the English language. Karl Čapek introduced robot, Isaac Asimov introduced robotics. And as I say, I regarded them as great written science fiction, but I didn't see how they'd ever be able to film them particularly interestingly. But that proves that I'm not particularly creative, because they have made a movie of iRobot, and it didn't get particularly good reviews, but I quite liked it, and I quite like the idea that it's a Hollywood thriller with lots of car chases and bangs and explosions and so on, but it's themed around the 3 laws of robotics. And Will Smith, as a detective, has got to try and figure out who's the robot and who's the sentient robot in amongst those. And I'll give you a clue. Will, sentient one's just in front of you. He's the one looking off to the left. I like the idea that it took the themes of Isaac Asimov's work and turned them into your average Hollywood thriller, which is good. Another of Isaac Asimov's books that I really liked when it came out, which was also turned into a movie. Again, not an absolute blockbuster, but still fairly well received. There's Robin Williams as Bicentennial Man in 1999. The original Isaac Asimov novel was called The Bicentennial Man, and it was written in 1976. His publishers, I think, suggested that he might like to write a book themed around the American bicentenary of 1976. And Isaac Asimov, at this stage, it's one of his better novels, I think. Is that he used almost the story of Andrew, the android who becomes a man by the end of the movie, as an allegory for those 200 years of the history of the United States and the civil rights advances that occurred during that time. So once again, the book was reflecting the era in which it's written, and then the movie takes on from the book and uses a similar sort of thing. It's a little bit mawkish. I think Robin Williams was produced quite sentimental movies around this period of his life, but again, it stuck quite close to the original idea of the book. Is you start with a robot, and gradually, as through the course of his long life, he becomes more and more human, and his quest to become accepted as a sentient being with as many rights as the humans amongst whom he moves. So you're getting more towards the cerebral science fiction that is trying to understand how we would react to not so much robotics, but as artificial intelligence, and in particular sentience. And of course, there is a movie called Artificial Intelligence, AI, 2001, the Spielberg movie, again, which I quite liked, of a young boy robot and his movements amongst, first of all, amongst the human population, and then amongst the robots with whom he comes to live. It's based on a Brian Aldiss novel, isn't it? So it's got good source material to it, and Spielberg, of course, is a great director. So I mean, I think you do see in recent years this idea of trying to explore what sentient and having another sentient species almost amongst us would actually mean for humanity, how we would react to them, and what could we learn about our interactions amongst our own species and apply to it. There's that excellent Channel 4 series, Humans, about sentient robots. First series at least was excellent, sort of went off by the second series, but in taking these themes of what does it really mean to be a sentient being, and what rights do the people actually have, and all these are, well, the movies that I've shown you are sort of kind of quite optimistic in some ways, but anybody who's ever interacted with British Gas, say, and the other companies that are applicable, trying to interact with their chatbots, will know that the reality is a little bit far from idealistic, and so perhaps for most of us the portrayal of artificial intelligence and sentient robots is best summed up by my favorite robot, and I'm sure yours as well, Marvin, paranoid android from the Hitchhiker's Guide to the Galaxy. Isn't it the case, I think, though, if we are artificial intelligence, you get artificial depression and artificial morosity and so on coming along with it. I think that's probably far clearer, far closer to what might actually happen when we get truly sentient beings actually happening. And again, don't know about you, neither of those two incarnations of Marvin matches my own mental picture, which I think probably tells you that radio and books are probably much better for creating the worlds. You create your own world with Marvin, who, to my mind, he's an android. He's not a robot. So perhaps the guy with the head the size of the planet in the bottom right is maybe a little bit closer to how I'd imagine Marvin. But I always assumed he'd be sort of morosely human in his incarnation. So that tells us the way that science fiction is going, and you'll notice in each of these that the robot is universal. It can do anything. Might grumble a little bit, might try to kill you, but it actually can focus on the task in hand and do it, and probably do it better than you. Certainly kill you faster than I could. But it's the reality, as we know, is that robots are actually the robot in the sense in which Carol Chapek originally described as their workers. They are literally doing the jobs that automation put them there to do. These days, the cars in the Ford factories are not manufactured by humans anymore doing the jobs. They're manufactured by robots, a machine that does one job very well and does the same job exactly the same each time round. So we've moved away from that universality in our own world. It's purely the cultural ones that make that have universal robots. And I think with the second part of the talk, I'll sort of talk about some of the robots that are up there in space, and try and trace the fact that universality is coming to us. It's not there yet by any means, but perhaps the real world is catching up on those visions of science fiction. So I'd like to sort of concentrate on the planet Mars. I mean, we've sent lumps of metal up to various worlds in the solar system, to begin with the moon because it's the easiest to get to, and then to Venus because it's closest, not necessarily easy to get to, and certainly not very easy to stay on for any length of time because the surface pressure, the sulfuric acid, the temperature, and all the other things that make it not a very nice place to live. Mars, on the other hand, is a lot more pleasant. Still flipping cold, I think, if you actually go there, but it has a slight atmosphere. It looks rather more like Earth, and it is somewhere on which a space probe can actually work, can actually thrive for some length of time. America and Russia through the 1960s sent a series of probes to Mars, initially not very successfully. To begin with, the hit rate was not good at all. Missions would miss the planet, head off into outer space, or they'd crash into the planet and destroy themselves. To the extent the joke was that there was a sort of monster somewhere close to Mars that flipped a coin and decided whether or not the mission was going to be successful or not. So in the early years, progress was quite slow. That first of all, they got Mars orbiters, Mars flyby missions that took pictures of the planet, proved that there weren't canals built by sentient beings or all the other things we'd rather hope might be there, that it was a cratered world, a little bit like the moon, and then took a little bit closer look and realized that although there were craters there was an atmosphere and there were some superficial resemblances, at least, to the Earth. The first landers that the Americans put on there were the Vikings in the bicentennial year of 1976. A very successful. I think they really did want to put something onto Mars in 1976 to celebrate their bicentenary, and why not? But essentially, they were static. They landed there. They touched down. They had a strong suspension. It went down on a parachute and landed bang. And if they'd landed on a rock, they'd have toppled over and never been seen again. And fortunately, the mission controllers picked sensible places to land them, where there were fewer rocks around, and both the Viking missions actually survived. The thing about Mars is that the atmosphere sort of doesn't really help that much because it's very thin, so parachutes don't slow things down very much. So you're going to have to figure out some way that your Mars probe can survive a pretty fast incoming landing. So the Vikings did so by having very strong springs on them to let them land without breaking everything on board. But as I say, they were in place and they couldn't move then. There could have been signs of life just out of reach, and they wouldn't have been able to actually touch them. If you remember, they did do experiments in situ experiments, taking Martian soil and doing various reactions to see whether or not life was present. And if you also remember, they actually passed some of those tests, which is a little bit embarrassing because nobody now thinks that those experiments were actually particularly suitable for detecting life. What they did detect was very strong chemistry from I think peroxides on the Martian soil. I think there wasn't sufficient understanding of what the Martian surface was actually like. So we came back. It was pretty quickly realized that if you're going to put a rover onto the Martian surface, you're going to have to do something other than let it land on springs and so on. So the next solution chosen was an airbag. You put it inside a bag and let that bounce around a bit and then deflate and hope that it turns up somewhere sensible. So the first rover on the surface of Mars was Sojourner in 1997. Tiny little thing, an absolute masterpiece of miniaturization, and was able to do its job well, astoundingly well. I think as a first go at a Martian rover, it was a huge success, and it became to be loved. I think that you could see the anthropomorphization of it down there in the bottom right hand corner. I think that was a very canny move by the mission people, that is to make people care about the rover. Another good move was to let the public decide what the rover was going to be called, and it got called after Sojourner Truth, this lady here, the human rights campaigner, African American. Again, very canny move by the mission people. It brought people on board to care what this rover was doing. And this little rover had a little laser so that it could blast small holes, very small holes in the rocks, and then a spectroscope so it could analyze what the rocks were actually made of. And it tootled around, didn't go very far, but didn't really have to. It could get to rocks that were of interest and start examining them. And it was a huge success. And inspired by that, and what it found was that there was every evidence there that Mars was not the dead world that the Mariner probes in the 1960s had suggested it might be. The pictures they sent back appeared to show something almost lunar-like. but when you got down to the surface, you realize there's evidence of water having flown at some stage during Mars's history. And so where there is water, there is every chance of life. And so that inspired a lot of money to be spent on succeeding probes, and still to this day that we're sending stuff to Mars to find whether or not there's a case. I think the jury's probably back in again to say that there isn't life on Mars at the moment, but it's possible still that we might find life, signs that there was life at some stage in the early history of Mars when there was still water around. So the next rovers were Spirit and Opportunity, rather bigger than Sojourner, still arrived in an airbag and bounced around, getting towards the limits of what you could do with airbags, I have to say. These were spectacularly successful. Opportunity was active on Mars from 2004 to 2018, 14 years. That is extraordinary. During that time, it traveled further than a marathon. Marathon's 42 kilometers. It went 45.16, and it visited several craters: Eagle, Endurance, Victoria, and Endeavour crater. Just a stunning success. Spirit was going for 5 years as well, till it got stuck in a sand dune and couldn't move any further. And so the Opportunity carried on until eventually it got too much sand on its solar probe, on its solar panels, unable to charge up its batteries, and it signed off and never signed on again in one Martian night. But they were two of the most successful missions ever, and were able, in the traveling 45 kilometers, you can investigate a lot of interesting sites and take a look at a lot of Martian geology, areology, isn't it? When you go to Mars, it's no longer geo. So I would say I ought to pay some tribute. The previous record holder, Opportunity, is, I think, still the farthest travelled rover, and the previous record holder was Russian, the Lunokhod rover, that tootled for 42 kilometers, again nearly a marathon, around the moon. I think the idea of Lunokhod was that it was supposed to support the Soviet manned moon mission that never happened. But one should give them credit. I mean, it's pretty spectacular. They got the Russians managed to get moon rocks back, and they managed to land a rover in the 1970s on the moon that survived long enough to be able to travel lots and lots of kilometers. I'll also point out 45.16 kilometers in 14 years is about 10 meters a day. This is not a probe that traveled a long distance. So we move on to the next generation, and now various things have happened. These are much bigger. The Curiosity rover in 2012 and its big brother Perseverance, they're essentially much the same rover. They've upgraded Perseverance, but they're both pretty large. And Perseverance is the size of a family car, and when you throw that at Mars, well, it's going through the atmosphere. It's still traveling pretty quickly, even with the biggest parachute that you can actually attach to it. So if you're not careful, it's just going to thump into the Martian surface, and that's the end of your rover. So they actually landed this by a skyhooks on something that essentially hovered over the surface, fired its rockets long enough to be able to lower the rover down on a crane to the surface, and then the skyhook would detach itself and fly away. It's extraordinary engineering. You think that seems to be an absolutely lunatic way to actually go away with landing something on another planet. So many things that can go wrong. An absolute tribute to the engineers from NASA and JPL and so on, who were able to build a rover that works and can be delivered to the Martian surface in such a way. I'm full of admiration for them. It's engineering at its finest. And you can see the cameras on it are high mounted, and they're stereoscopic, so you can judge distances with them. And they figured out all the lessons that they've learned from Spirit and Opportunity. The wheels on the rovers are better designed for the very sharp Martian surface, and so on and so forth. They've learned their lessons. And the Spirit landed in the Gale crater, which you can see there, and in the middle of the Gale crater is Mount Sharp. It's Aelius Mons or something like that is its actual technical name, but it's named after one of the people connected with the mission, and it's gradually edging its way up Mount Sharp as we speak, as it's still on the Martian surface, still reporting. Perseverance, on the other hand, landed just a couple of years ago in Jezero crater, and Jezero is Bosnian. You see how much research I've been doing for this. Bosnian for lake, named after a town called Lake in Bosnia, because they think that this crater was originally at some stage flooded. So this is an absolutely perfect place to land, to study what Martian water might have done and whether or not it's left any traces behind. And on the seashore, it's perfectly good place where you might start seeing life. And of course, the great thing, the great difference that made Perseverance different from anything else is what came with it. Strapped underneath Perseverance on its way down, and then Perseverance rolled out the way to reveal Ingenuity. So Percy and Ginny sat there on the surface of Mars. We're going to be flying, or we are now flying on the surface of another planet. I'd never, not something I expected to be able to tell you. So there's Ingenuity in motion. This is there it is in the bottom left-hand corner there. One of its flights. It's designed for flights of up to 90 seconds, but I've seen, looking at the mission logs, that they're approaching 3 minutes for the flights. So it goes up into the air, it reconnoiters where it is, figures out where it's going to go, and it's going to shoot off to the right in a moment or two. There we go. Doesn't that look, it's recognizably Martian. The sky colors are not what you normally expect to see on Earth, but at the same time, it's recognizably terrestrial in its things that we recognize, hills and valleys and boulders and so on, but at the same time, utterly alien. You feel like you'd be at home there, even if when you got there, you discover Martian gravity is only about a third of what we have on the surface of the Earth. So there we go. That's one of Ingenuity's flights. I had a look on the flight log. It's up to number 33 now of its flights. That's not the next flight along. That's just repeating the one that's already there. But it has a couple of jobs really. I was going to say, no, flight number 33. There's something attached to Ingenuity, which is rather scary. I didn't realize plastic bags had gone that far, but it looks as though it has picked up a bit of litter along the way. There is no litter there, so goodness knows what it is. They're still trying to figure out whether or not it's a bit of Ingenuity or a bit of Perseverance or a bit of the parachute or something like that. Who knows what it actually is. But its job is kind of twofold. Number one is to kind of reconnoiter for Perseverance, is to go ahead and look down and see whether or not there are any sand dunes in the way. Is what's just over that hill there? Is it safe for Perseverance to go? And its second job is to go places that Perseverance definitely can't go. What's in that ravine over there that Perseverance would just crash into? It's I mean, I guess a third, or the zeroth task for it, is to prove that we can fly on another planet. I mean, again, just extraordinary. A century on from the Wright brothers, whose first flight lasted 12 seconds. Well, Ingenuity's first flight was closer to 60 seconds. I think it was. They were already beating the Wright brothers even on their first flight, and who knows what will actually happen. But this is kind of my point, is that what we're moving toward is a sort of integrated transport system on Mars. That Spirit moved 10 meters a day, and the reason it was doing that was they had to be very careful of what was happening. They didn't want to drive the thing into a sand dune. If you watch the Big Bang Theory, the American comedy series, you might remember the episode in which Leonard lets his girlfriend at the time, Stephanie, drive the Mars rover, and she drives it into a sand dune. She crashes it. This will not happen in real life for all sorts of reasons. Is that first of all, they wouldn't let people without the right qualifications anywhere near the control room. But more importantly, that's just not the way they move the rover. You can't drive it in real time because Mars is so far away from the Earth. It takes a quarter of a second for a radio command to get to the moon. No, it doesn't. It takes more than that. It takes about a second or so for a radio command to get to the moon. It's a quarter of a million miles away. It travels at the speed of light. Mars can be anywhere from quickly does the mathematics, from a few minutes to closer to an hour. So there is no way you can drive these things in real time. And with Spirit and Opportunity, what you did was figure out where you were going from the view that you could see, and send the commands to the vehicle to say, okay, move forward 10 meters, because we're quite certain, because we can see it, there's nothing there that's going to stop you. And they had to take it on trust. Back came the pictures, and they found out whether or not they were able to move 10 meters, or if it had hit some sand and was stuck or whatever. And if it hit a problem, then they'd have to sort it out very carefully, without try and do something that didn't make the things any worse. Now, this is still the case that they're going to tell Ingenuity where to go, but things are far more autonomous now. It can make decisions for itself whether or not it needs to stop. It can check things out along the route, and it's got Ingenuity to scout where it's going. So Ingenuity, Perseverance can move a lot quicker than either Spirit or Opportunity. It has a little helper to help it. It also has artificial intelligence there. We've come a lot further in self-driving technology on Earth, of course, and we can use that on Mars to try and figure out what's up ahead and whether or not it's going to stop us. So let me go on to one or two other robots. Again, other nations have reached Mars. It's something of a test ground these days, isn't it? There are Chinese and Japanese and Indian probes in orbit around Mars, and the European Space Agency has done its best to land on Mars. Not tremendously successful. Mars Express as an orbiter has done very well. It's still one of the workhorses that sends signals back to Earth. But the lander, famously Beagle 2, our great British space probe to Mars, I could say crashed, but it didn't. It was so nearly a success. It landed on the surface, it unfurled one of its panels, the second one and the third one failed to deploy properly. And so we didn't know what had happened to it for many years until one of the orbiters managed to image it. And unfortunately, Colin Pillinger, who was the project scientist, didn't live to know what had happened to his baby and how close it came to succeeding. And then we had the ExoMars probe the other year that unfortunately decided had already landed when it was still several kilometers above the Earth, above the surface of Mars, and therefore deployed. It went into landing mode several minutes too early and ended up just crashing into Mars. We forget, following all these very successful, mostly successful American missions, that it's still difficult to land on Mars. But hopefully, before too long, we will get a Mars rover, and this is it. It's called Rosalind Franklin. Another great choice of name for the Dark Lady of DNA, somebody who really deserves to be remembered. It was due to land in 2020. As I was looking back on my previous incarnations of this talk, that when I started out, it was going to land on Mars in 2020. This was put off by the pandemic, and it was due to land on Mars in this year, or at least set off for Mars this year. But unfortunately, global events tend to get in the way of these things. You should really, if you can launch when you can, do it, because things may happen, like pandemics, or like falling out with the Russians because they invade small countries who are minding their own business. Unfortunately, it was going to be launched by a Russian rocket, and now it can't be anymore. And so who knows when it will actually take off. It's now scheduled tentatively for 2028. I think they'll be able to launch either with an Ariane or with an American launcher. They do have to take off some of the Russian experiments that are on board, because we've no longer got cooperation going on, unfortunately. But it could still happen. They may take the chance to upgrade certain bits of it. I was reading that they were going to put some shake technology on to try and shake dust off the solar panels, because that's what seems to stop Martian rovers in the end, that they get too much dust on the solar panels, they can't recharge. So perhaps something good will come of it. I also read that the sort of mission Spare, the second one that they were going to send, is no longer going to go to Mars, because by the time they get around to launching that, better things will have come along. And I've seen articles that say that they may repurpose that to send it to the moon. I'm not convinced, because it's built for Mars. The solar panels are built for the amount of sun that falls on Mars, and It's rather different on the moon. The wheels are, the suspension is built for the Martian gravity and not for the gravity on the moon. So it's not optimized for traveling on the surface, and that's kind of asking for trouble, I think. And I also feel sad for this extraordinary young woman, Abby Hutty, the IET Young Women Engineer of the Year 2013. She's an engineer on ExoMars. She came and talked to us in Coventry for our Christmas meeting of the Learner Societies. We always have an excellent speaker, and indeed Abby talked to us a few years ago about ExoMars. And I wonder whether or not she's still working on ExoMars. It's space missions can be difficult for early career engineers, because things can happen that suddenly put them off by 6 years or so. Will she move on, or will she stick with the project that she was doing such a good job on? I don't know. We might find out, because Derek was telling me that he's hoping to book her as a speaker at next year's Robot Day in Coventry. So perhaps we'll have an update on what's going on with the ExoMars rover. I certainly hope so. I realize I'm already out of time, and I thought this was going to be a short talk. So if you don't mind, I'll carry on a little bit longer. I want to talk about even more autonomy that's going on some of the other probes in the further reaches of the solar system. This is Comet Churyumov-Gerasimenko, P57, 57th periodic comet. And around it, the fantastic Rosetta mission from ESA. How on earth you put yourself into orbit around one of these things, I really don't know. How do you calculate what the gravity is going to do when you're flying around something that looks like a rather large rubber duck? The control that's got to be done to keep the thing in sensible orbit around something like that is quite extraordinary. Also tells us about comets, that what on earth's happening for these two large masses. Have they come together? Are they about to split apart? I think the jury is suggesting that probably the latter, that they were originally two large things that formed close and have gravitationally joined together, but it's not absolutely certain. One way that you might find out is by sending a lander down to land on the surface of a comet. This is science fiction, except that it happened. A Philae lander from the European Space Agency landed on the comet itself. It kind of landed. It had all sorts of experiments there, and the idea was that it was going to harpoon itself. It's going to send down spikes that attached it to the surface of the comet. But we don't know as much as we thought we knew about the surface of the comet. It turned out to be much harder, much more impenetrable than they'd expected. So Philae bounced off the surface of the comet, bounced around a few times, and eventually ended up in a ravine. But even more, so that, as they said, the European Space Agency people said they achieved the first, second, third, fourth, and fifth landings on the comet, all in the course of about an hour. Unfortunately, they were only expecting one landing. But when to everybody's surprise, eventually it woke up. I think anthropomorphizing these things gets the public on board. It sent back not as much science as they were hoping to do, because it didn't have access to that much sunlight. Didn't stay there for very long. But again, an extraordinary mission. And again, my point is that it's so far away from the Earth that you can't land that thing in real time yourself. You have to tell it how to land and let the control engineer and the artificial intelligence and so on figure out what you're going to do. So this is the universality that is creeping in of necessity by the laws of physics, that you can't do things in real time. You've got to let your autonomous robot do the work for you. I really love this one. Not a mission that has received too much coverage in England, because from the Japanese Space Agency, but there are two probes called the Hayabusas, apparently Japanese for peregrine falcon. And the first probe launched 2003, and 2 years later visited the asteroid Itokawa and dropped a Minerva lander onto the surface. And it actually managed to sample some of the surface of, first of all, look at the surface and then sample some of the surface, bring it back to Earth. The way they did that is they're powered by ion engines. Ions has 600 not kilograms, 600 grams of xenon shot out iron by iron at high velocity. If you took an iron engine and tried to launch from Cape Canaveral, you wouldn't get very far. It would just sit there. It's got nothing like enough thrust to get even started, even off the ground. But once you're in space, if you let one of these big bugger Arianes or Saturn V's or whatever take you up there, no, I know Saturn V's haven't launched in 50 years, but similar rockets, once you're up into space and traveling in zero gravity, then an iron engine can move you very slowly but remorselessly in the direction that you want, and it's perfect for sort of touring the solar system. If you don't care how long it takes, it'll get you there eventually. I mean, eventually the fuel will run out, but not very slowly at all. So Hayabusa was a great success. It did actually sample Itokawa, which turned out to be a metallic asteroid, like most of them. But what they wanted to do was visit a different type of asteroid, carbonaceous chondrite. These are much closer to the original conditions in the formation of the solar system. They are essentially material that has never been geologically or by any geological processes, never been modified. It's as it was at the beginning of the solar system. All that's happened is it's come together under gravity. They have it's called chondrules, which are the little kind of flakes or little beads inside them, and they are actually metallic drops that have frozen in outer space. That they're so you're talking about the birth material of the solar system. So looking at asteroids that are like that tells us so much about the early history of the solar system. Also true that they haven't had chance to collapse under gravity. These are very small asteroids, so no when you get to the sort of collapse as you get to the Earth, then the heavier elements, because they're heavier, sink to the middle. So on the Earth's surface, heavy metals and heavier element materials are deficient. There's not that many of them. That makes them very rare. Whereas on asteroids, they haven't had the chance to differentiate. So it's quite possible that asteroids will contain much sought after minerals and elements and so on that could make them commercially viable for mining. So very interesting to prospect these things. So Hayabusa 2 wanted to visit asteroid Ryugu that had been identified as potentially carbonaceous chondrite. And it actually, quite impressive. I say 2 there, but they actually had 4 landers, the Mascot and Minerva 2, which I think had 3 separate robots, one of which didn't work. But they hopped around. They had little reaction springs inside them that caused them to bounce. Not very much gravity on an asteroid, so you could just hop around without doing very much, very gently, and go from place to place. First ever pictures from an asteroid. That's what an asteroid looks like. Sorry, that's the Mascot being dropped away, I think. And then it lands on the surface, and well, as you can see, it's a rubble pile. It's very porous rubble pile. It really hasn't collected together very much under gravity, and so you can see these things here. There's the surface of it, and remember, this is pristine material. It might just look like a dirt pile or whatever, but actually this is gold, not genuinely gold dust, though there may be gold there, but gold dust, stuff that scientists would really like to study. So Hayabusa had plans to actually collect some of this stuff. What it did was get itself near to the surface and fire, I think it was either copper or tantalum, one of the two, at the surface to create a crater. It moved itself out of the way, and well, it was doing this just to make sure it didn't get hit by anything, and then it returned to go very close to the surface, drop down, send another projectile in to knock up dirt or whatever was on the surface, collect it and store it away, and then it was able to return on its iron engine back to Earth. Okay, so this is, let me see if I can launch the movie for this. It's going to happen. There we go. Going down, it's going to make its way down to the surface, in very gradually, and woof, all that material shoots out. Some of it will go into the storage canister, and it's now moving itself out. And again, my point is that this is impossible to do in real time. All this has to be done by software that is capable of reacting to slightly unforeseen circumstances. If major things went wrong, they'd struggle, but it has to be able to figure out all the things that might happen and then go with that. So more and more autonomy from these things. And it landed sort of on Ryugu, collected surface particles. It headed back to Earth on its ion engine, flew by in December 2020, dropped off a canister. It's launched it through. It landed in Woomera in South Australia. It will then go on. It'll visit Apophis, which is the asteroid that everybody thinks will collide with Earth. Well, it'll make a visit there and scout it out, see what's about to hit us in a few thousand years' time. Or not, but it created Hayabusa, who collected and delivered back to Earth, they think, about 200 millimeter sized grains of carbonaceous chondrite material, about 5.4 grams. Not to be outdone, the Americans have got a similar mission, OSIRIS-REx, that has also visited Bennu, which is another carbonaceous chondrite asteroid, and it has collected, they think that the mission was due to get 60 grams, and they think they've got anywhere between 400 and 1,000. So a great triumph for Japan, and a great triumph for America. A cost for in each case of several $100 million. Meanwhile, 340 grams of similar material landed on the drive of the Wilcock family in Winchcombe, Gloucestershire in February 2020. There it is. They're pointing out the dust. I think the main portion of it's already been taken away. This is, I mean, pristine material from the birth of the solar system landed on their drive in Gloucestershire, narrowly missing the guinea pig hutch. And I mean, this is like, I can't tell you how pleased the people were at the Natural History Museum. They got there. They didn't have to wait 30 years for, or 15 years or whatever, for their for a probe to actually come and collect them. It got delivered to them. And I want to say a triumph for my friends in the amateur astronomy community. A lot of what made this happen. England is very well served for looking at meteorites. Many of my friends have got cameras on their roof, all sky cameras to detect meteors. And all the luck was on our side. That February evening was a clear night. So many people saw the fireball of the meteorite as it arrived, and so people were aware something was happening. Everybody I know checked their meteor camera, and so we were able to get 6 good traces of where the fireball went, its height in the sky, the direction it was traveling. You can triangulate from that, and they knew something was likely to have fallen near Winchcombe, in Gloucestershire. They didn't know exactly what address it was or anything like that, but they were there, and they alerted people. It was on the TV news that fireball was due to a meteorite. There was a possibility of meteorite there. So Hannah, in the middle there, heard a bang, and then the next morning, when she went out the house, she spotted they thought it was a bit of barbecue, essentially, that somebody had thrown on their drive, but realizing that nobody's going to have a barbecue in the middle of the pandemic in February, they remembered what was on the TV. I think they called their son, I think, who said, "Oh yeah, there might be a meteorite." So bless them, they didn't collect it up and put it on eBay. They didn't put it anywhere near an electric field or a magnetic field, which is good. That would have destroyed information. They put it in a plastic bag, put it in a plastic box, and called the Natural History Museum, who arrived there and were ecstatic. Less than 1 in 20 meteorites is carbonaceous chondrite, and this huge one, 340 grams, is pretty big for a meteorite, had arrived in England for the Natural History Museum. Almost everybody I've ever seen giving a talk about meteorites, Sarah Russell from Natural History Society, Katie Jai from Manchester, visited the Wilcock family at some stage to salivate over what they just got there. And hopefully, I haven't been there yet, but it's on display. Much of it's on display in the Natural History Museum, along with the drive, which was scooped up off the ground by a contractor, so that they could hoover every last bit of this. This is so valuable. You know, they could sell it for a heck of an amount on eBay, but they didn't. They donated it to the Natural History Museum. Well done. These people are amongst my heroes. They got honorary degrees and things out of it, but you know, they did the right thing with the meteorite that fell on their lawn. On their drive. Again, off subjects a little bit, but I really love this. It's cities and science as it should be. I'll finish with a couple of things from the future. What we might be telling you when I gave this talk again in 22-23. A couple of missions that are coming up, one in the near future that will happen, and one that might. Yeah, robots. We're going to have robots in space for the foreseeable future. They don't breathe or eat or drink. They can be switched off for years. A friend of mine, Nick James, is one of these people who has a meteor camera on his roof, but he also works in the space industry, and he was involved with Rosetta. He was there in the control room when they waited to see whether or not Rosetta would switch on again after 2 years of radio quiet in space. And if it hadn't signaled back to them, they'd have lost the mission completely. So it's one of those moments you wait for, and then suddenly there's the signal from the space probe, and they can carry on with the mission. You can't do that with a human being. We haven't got the technology yet. Maybe we'll be able to put people into deep sleep, hibernation or whatever, but we can't for the moment. Artificial intelligence is only going to improve, and so we might need these things to go even further than we have done so far. So one mission. This one is been funded as part of the NASA's New Horizons program, scheduled to launch in 2028 to get to its target in 2034. This is Titan and the Dragonfly mission to Titan. You might remember Titan is the world on which we've landed the furthest space probe that we managed to put onto another world. It's the Huygens probe, which was part of the NASA's Cassini mission. The European Space Agency attached a lander to it that landed spectacularly successfully on Titan. The mission scientist John Zarnecki from the Open University came to talk to us in Coventry about it. He got lost on the way to Coventry, which didn't fill us with much confidence that that he'd be able to land something on Titan, but he did. It was a great success. Went through Titan's methane atmosphere, landed, and returned pictures of again what looked like a stream ditch from Earth, but wasn't. The rocks were not rock; they were frozen ice. Well, now we're going to send a helicopter to Titan. With success of Ingenuity on Mars led people to realise that we can explore these things. Titan has a very thick atmosphere of methane. That the atmospheric pressure is 50% more than the Earth. Gravity is not very strong, being as quite small moon. Big by moon standards, but small by planetary standards. So it will be perfectly capable for this to land by parachute, and then having landed, it can take off and investigate its surroundings. A little bit different from Ingenuity. Ingenuity has solar panels on its top so that it powers itself that way. Titan is too far away and the atmosphere too thick, so there's a radioisotope that charges up the batteries thermally. But imagine being able to fly around a whole new world we've only just started to explore, taking pictures as you go, and actually getting an idea of the Titan, the lakes at the poles of Titan, and the sand dunes or the ice dunes that are there. It's going to be fantastic. I'm looking forward to it. Hopefully I'll be 72 in 2034, so I hope it doesn't get delayed too much, but every confidence that I should be able to see the thing. But I'm also a little bit I'm dreaming of the day that we put humans onto Titan, because the atmospheric pressure on Titan is so high and the gravity is so low that if you put a man or a woman on Titan and gave them wings, they could fly. Put me down for it. There are problems. The average temperature on Titan is minus 178 degrees, so they've got to wear their thermals or whatever. But it's once you're there and you've insulated yourself, and you've got to have your own air supply because you can't breathe methane, then you can fly on Titan. And for all that we put a helicopter there, and the pictures will be fantastic. Imagine the day when Titan becomes a tourist destination. It'll just be fantastic. Probably won't be around for that, but if you are, well, count me in for it. Maybe a Zimmer frame can fly. We will see. Looking further ahead, the final slide in my talk is this breakthrough star shot. That it goes. This is a feasible, maybe, probe to the next solar systems. And I say feasible because they think there are no actual laws of physics that can't stop you sending a solar sail to the next star in human lifetimes. That if you can focus the laser on a sail, then the radiation pressure will accelerate it. If your sail is made of nanoparticles or is made extremely thin, then that acceleration will get you up to very high speeds. And the calculations are, I'm not quite sure what's going from the Earth's surface. I'd put my laser in orbit, because that way you don't get any attenuation through the atmosphere. But if you can keep it pointed on your solar sail, then they think they can get up to a substantial portion of the speed of light, to say 1/10 or 1/5 of the speed of light, which would enable us to get to the next star system in tens of years. Next star system being Alpha Centauri, and that's a double star, and around it is Proxima Centauri, around which we think we have detected a planet. There's a whole movie about it, Avatar, but that's not the planet that's been detected. Imagine being able to send a solar sail to to Proxima Centauri to take pictures of whatever happens to be around there. Obviously, you have to nanoize absolutely everything, the cameras, the communication systems, and so on. But the people who've done this, the breakthrough initiatives, I would strongly suggest you go to it. Think that it's just engineering problems, not fundamental science problems, which means there's probably a manager that's there saying to some poor engineer, yeah, make it happen by next Friday, and you've already used up all your budget, so don't spend anything. We're at that sort of level with it. I really hope this sort of thing happens in my lifetime. We're getting on a bit, they'll have to get a move on with it happening. But the fact that they can't find anything fundamentally wrong with it suggests to me that it's kind of like gravitational waves. It will probably happen at some stage in the next few decades. And it will only happen if you have autonomous intelligence looking, you've got to be able to take the pictures and send them back and figure out what you're looking at and where to point the camera and everything else. And you've got nobody telling you to do that, because it takes 4 years for the commands to come through. This will all have to be done by AI. So this is the future. I think the robots will be able to take us to places that we can't possibly go at the moment. The skies of Titan, the fiery depths of Venus, into the atmospheres of Jupiter and Saturn, down the geysers of Iapetus and Triton, into the oceans of Europa. They can go there because we're getting from robots that just do the tasks they do to universal robots that can do everything that they need to do to accomplish the wider task. But I also hope that one day we'll be flying in the skies of Titan, because I think experiencing these things vicariously, it's great and inspires us, and actually being there, but getting a human being to do it from themselves is really what we should be doing as a species. So the robots are there to help us out, but I really hope that in the long run that the humans will be there as well. Thank you very much.
Wow, that was fantastic, Mike. Thank you. Your enthusiasm is palpable, and I can tell from the chat that we've been having that it's infected the audience as well. Fantastic. So we've got a heap of questions come in on the Q&A. So Mike, questions and answers. How long have you got? We've got a lot. We've got a lot of exciting questions here. I don't think that they've let themselves down. They probably give the 10-year-olds a run for their money, I think. So without further ado, Leo asks, I'm studying robotics engineering BEng honours. Have you got any advice for starting a career in the space industry?
Abby works for Astrium EADS, doesn't she, in Chelmsford, I think. So they'd be a very good place to start to apply to. They seem to do all the work for the European Space Agency here for the actual building of the stuff. And I think my friend Nicky's also Chelmsford based, so that's kind of suggesting to me that's where you go to do the engineering on things in the UK.
Yeah, also BAE Systems, obviously where Abby started out, University of Surrey, where I believe she's also involved currently, and we've got the spaceport in Cornwall, possibly a spaceport coming up in Scotland as well. So it's a really exciting industry already in the UK, and a lot of opportunities coming up. So there is also an organisation called UK SEDS. That's UK. It's an organisation for UK students involved in in space activities. So if you look for UK SEDS, SEDS on the internet, search that up, you find some opportunities to network with fellow students. Thank you. So the next question from Alex: how did Spirit and Opportunity survive the radiation up there for so long? Was it down to old lithography in their chips?
Well, it's a good question, isn't it? I mean, you have to build the. And telling me that I had to move my my microphone a bit. Sorry, I've gone quiet. I mean, you have to space harden these things, don't you? And I don't know a lot about the engineering behind those things, but yeah, I mean, it's extremely hostile environment. Surface of Mars is an extremely hostile environment because Mars doesn't have anything like the magnetic field that we do. It has little bits of magnetism left over from its tectonic era, but it's the radiation gets down to the surface and will do damage. So whatever you do, you've got to protect it against radiation. Well, first of all, in space while you're actually getting there, and it doesn't relent when you're on the surface. So everything has to be protected, and that's part of the design for it. So I don't know very much more about how you protect the chips, but you got to do it.
Okay, thank you very much. So next question from Soam: if we look towards AI-based space exploration systems, how do you see its feasibility and technology readiness levels currently and across the next decade?
Yeah, I mean, again, it's an interesting thing with space travel, of course, is everything tends to be 15 years out of date, because what you have to do is use the technology that you know will work. So they're not very advanced in what they use. So we know already that we've had another 10 years or so of development of AI and of, for space probes. And we know self-driving cars work pretty well. So we can be pretty confident that things are going to progress forwards because we've already seen the future in that respect. So I think I'm very optimistic, that the helicopter on Titan will work really well. I think they're kind of punching the air when Ingenuity got off the ground. Yes, now we can put a helicopter on Titan. We know what to do with it, and it's going to be good.
Excellent, thank you. And that segues quite nicely into Patrick's question, which is: what synergy and crossover is there between planetary rovers and the autonomous car industry?
Yeah, well, exactly. Yeah. I think the synergy, I suspect it. I was going to say it probably goes more from the car industry into the rovers, but is that really true? I know it's the classic thing. Is one of the reasons people do space science is because of the payoffs that it has on Earth. So maybe what they were all the self-driving car companies had people who got experience of Mars rovers. maybe that's what happened, is that you acquire the expertise. You acquire the expertise working for NASA, and then somebody pays you a whole load of money to go and build a Tesla that drives itself around California. So yes, I think the synergies are absolutely definitely there. Obviously, there's different set of perspectives. You've got to worry more about your laws of robotics in the car, I think, because you are going to interact with human beings rather more on the streets of San Francisco than you are on the dunes of Mars.
Yeah, my own research touches on that kind of thing, and it's going to be a long time before we see autonomous vehicles on the roads, because we've got humans involved in the system as well. But we're already quite advanced with off-road autonomy. So there's a lot of autonomy used in mining, for example, and I can see that that there's a very important role for the lessons learned in mining autonomy for rovers, especially with sample taking and so forth. So Beth asks, how long do you think it will be before we have genuinely sentient robots, assuming we don't already? How do you test for this? And then Chris raises an interesting point, which is related to that, saying, is it a binary value or is it a continuum?
Yeah, I wonder if it might be the continuum that we get gradual. As they say, we've already got artificial stupidity. When are we going to have artificial intelligence? That Honestly, I don't know. I mean, that's the chap from Google who claimed they'd already got artificial intelligence. I think he was somewhat shouted down. And the other thing, against very Asimov quote, isn't it? The first inkling will not be will not be suddenly the robots rise up. We've got Judgment Day. It'll be, oh, there's that's a peculiar result. You know, something. The first signs will kind of be subtle. So I don't know, but it's kind of feeling we're kind of getting near the threshold, I think. What do you think, Stephen?
Yeah, I don't know. I think that question of the test. Turing famously came up with the Turing test for sentience. I'm not sure he was right on that, despite his unrivaled genius in many other things. It's very difficult. We people have been fooled by them in particular contexts, and in a particular context we might be getting close, but if you talking about general artificial intelligence, I think we're a long way off. What is the formal definition of the difference between a robot and a machine, asks Charlie. For example, Ingenuity or any drone versus a standard helicopter or aircraft, or any of the satellites in orbit around us.
Yeah, well, I mean, Ingenuity, Ingenuity kind of decides. Ingenuity decides whether or not if it can land and so on. It has to make decisions for itself. But I mean, I'm kind of told that most commercial airliners could actually do almost all the flying themselves. They just need the pilot there to make sure there's a human in the loop. So how different are we from how different are we with our helicopter from Mars from many commercial airplanes? So I'm not sure it's I don't think there's, I think we're blurring the difference. I think that the more sophisticated the machine, the more it's acting like a robot, the more autonomy, universality that it has, and I think that's just going to continue.
Well, like yourself, Mike, I do a lot of volunteering with young people, and I have a talk called "Is My Washing Machine a Robot?" And so, drawing on the wisdom of the young, when I run that workshop with the young people, they've generally decided, yes, my washing machine's a robot. So
really. Okay.
If a washing machine's a robot, then I think that the threshold is fairly low. So Keith asks, what is the balance of autonomous control and manual control from Earth with current rovers?
Yeah, well, I say 20 years ago it was, today we're going to go from here to here, and now it's more it's not quite see how far you can go, see how far you can push it. It's more it's giving the machine a target as to where it should go, and it trying to figure out its own way of getting there. So it's I think the balance is moving more and more towards autonomy, and of necessity. I mean, you can't you can only get so far going 10 meters a day. You're not going to get to the top of Mount Sharp like that. Maybe curiosity will. We will see. I think it has to be the only way you're going to make progress is to give them more and more autonomy. I think you're on mute there.
Absolutely, and especially if they're flying to other star systems, we're really not going to have a lot of control over that.
At that point, it's complete autonomy, but we're a decade or two off that yet, unfortunately.
We just got we've had a few questions coming in about the recording. A few people had a calendar mix up, unfortunately. So that will be available on the IET East Midlands YouTube channel. If you just Google IET East Midlands YouTube, give us a few weeks to get that edited and up there. But that's where you'll find it in due course. So Don asks, is there much cross-fertilization between the development of space and Earth robots, such as those for nuclear decommissioning?
Yeah, I think they did. The one I was reading up was, when they got to Chernobyl, the robots that went inside the reactors in Chernobyl were essentially lunacods that they'd sort of repurposed for it. So yes, I think that there is very much. The moon is a hostile environment, and underneath the reactors in Chernobyl is an even more hostile environment, I suspect. And of course that radiation hardening that you've got to get to go to the moon, that comes in useful as well when you're next door to a broken nuclear reactor. So yes, I think there is a lot of cross fertilization there, and I'm sure when Fukushima went up, the people from JAXA were probably quite heavily involved in trying to figure out what to do next with that. So yes, I think there is cross fertilization there.
Very good. So Alex asks, I think in reference to the solar panels, why not use wipers, like rubber wipers or a brush for the dust? They would seem to pay back the energy that they use.
Yeah, I'm sure. I don't know the answer to that, but I'm sure they've thought of all sorts of things to do it. And when Spirit and Opportunity went there, I don't think anybody was expecting the mission to go long enough that dust on the solar panels would become the limiting factor on it. So I guess they hadn't thought about the possible technology, and wipers would certainly be one. As I say, shaking seems to be another one. Maneuvering yourself in the path of a dust devil, that's another way they use on Mars, because you do get dust devils in the atmosphere, and they're very useful at blowing the dust off your solar panels. So there are means of doing it, and you wonder if windscreen wipers are actually proven technology. So why not use it on Mars?
Yeah, I've heard a similar answer before, which is that you're carrying extra weight. Every kilo you carry into orbit costs about £10,000. Adds complexity to the machine, and the winds on Mars are pretty extreme. So if you just sit and wait, the dust will get blown off eventually.
They're extreme. They're quite strong. Of course, there's not much atmosphere there, so they're not one of my favorite movies that we didn't talk about today because there wasn't that much robots in is The Martian, and as a lot of people have pointed out, the sort of storm at the beginning of it's not that realistic because there's just not enough air there to blow you over and so on. It's but it is strong enough to blow the dust off your solar panels.
So Leo asks, with advances in autonomous robotics like Astrobee and larger rockets like SLS and Starship, do you think manufacturing and construction robots placed in orbit or beyond is something we will see in the near future, or is that still the realm of sci-fi?
Yeah, I think at the moment it's still the realm of sci-fi, but it has to be the way forward. We've got to, you can't keep manufacturing these things and launching them up at huge cost. If you can do it more cheaply on the moon, say, or an asteroid or something like that. And I think possibly, that's one reason why we're thinking about going back to the moon. I mean, we know we can get there, and we now know that there are resources, water at the poles and so on. So that would enable us to start manufacturing stuff. And I think it's another reason why, there's a lot of everything on asteroids because of the way that they form. So they'd offer us the chance of getting source material that's already up there. So yes, I think in the medium, a few decades down the line, I'm sure we're going to see construction of stuff in outer space.
I wonder. I think that that materials thing is the key, because there's not much point carrying the materials up there and the machinery to construct them, because then you'd have to carry more up than you would have done otherwise. But perhaps there's an interim opportunity to pack things more tightly by having them disassembled and then assembling them rather than manufacturing them in space.
Yeah, and then of course we get the space elevators, and at which point everything becomes cheaper again, and we can all go to Titan for our holidays.
Just for those who don't know, would you like to explain what a space elevator is?
Yeah, well, the period it takes to orbit around the Earth varies how far away you are from the Earth. So if you're in low Earth orbit, it takes about 90 minutes, and then you get slower and slower and slower as you get further away, until at 22,000 miles, it takes 24 hours to go around the Earth. So you stay in position. That's why your sky satellite is 22,000 miles away, and so it's always in the same place. So if you were to lower a cable down from that 22,000 down to the surface of the Earth, and then attach an elevator to that cable. You could get yourself up, and the cost is only the going up the cable, which is not that much. You're not having to fight the atmosphere and everything else, and the going sideways to get yourselves fast enough to orbit the Earth in 90 minutes. All the things that make SLS rockets and Saturn V's so expensive to launch. So economically, that's the way forward. It's just that building a cable that's 22,000 miles long is a little bit tricky at the moment. We're a bit closer with carbon nanotubes and so on. I think that's the first material that people think, oh, maybe just maybe we will. And I think again, actually, if they do build a space elevator, the first one will be on the moon because there's no atmosphere there, and it's not going to be as long. So that will get you from your lunar base up into orbit around the moon.
A very good point. And a final question from Charlie: how do you cope with the rotation of the Earth if you're using the laser powered sails?
Yeah, that's why I think that picture is a little bit misleading. I don't think you put your laser on the Earth. I think you'd probably you'd certainly put it into orbit. You might put it at the same place where the James Webb Space Telescope is in one of the Lagrangian points, so that it's always pointing out in the same direction. So you need to think about it just exactly where you could put it, so you can always relentlessly shine the light on the probe. And again, I'm sure better people than I have thought about that, but it struck me immediately. Don't put your laser down there. Put it out in space. And then I think about it more. Well, don't put it in orbit around the Earth, because half the time will be behind the Earth. Put it either in orbit around the Sun or in the Lagrangian position, which is essentially an orbit around the Sun. So I think again, these are sort of engineering problems. They're not how to do it efficiently and sensibly, rather than fundamental things that are stopping us from doing it.
I suppose the power consumption might be an issue there. You might have to put it on Earth in order to generate enough power to fire the thing.
Yeah, I guess it depends on whether or not they'll let you send your nuclear reactor up. Yes, you're going to need a huge amounts of power, which is probably not achievable with solar panels. Just a finger in the air rule of thumb. So you probably need a very big power source. So I don't know how keen people will be for us to send nuclear reactors up. They're fine once they get up there, but the launch can be a bit fraught.
So that was all the questions we've had. Thank you for staying on to answer all of our questions this evening. That was absolutely fascinating. We've had lots of positive comments coming in on the chat. An interesting one here, bit of an in-joke here you might want to explain, or possibly not even. Andy says, bravo, Mike. Hugely informative and entertaining. I always wondered what you got up to in BR57A.
Yeah, BR57A is where I work in rugby, and I'm sure there are many people who wonder what the heck I'm doing all day. But I didn't admit in front of my potentially my bosses that I nipped outside to see the total eclipse, the solar eclipse on Tuesday morning. Really didn't do that. That's just a rumor.
Other people saying thank you for a wonderful presentation, a very insightful talk. Somebody wondering if Arthur C. Clarke was a sort of forerunner of if HAL was a forerunner of a cobot.
Yes, and the famous thing that HAL is one letter off IBM, which Arthur C. Clarke always denied. That I think we're I wouldn't like HAL to be my mission computer on my trip out to Titan. I think it would be.
And well, Gordon's just snuck in one final question about solar sails or laser sails. How would you avoid it being blown off by flows in the interstellar medium?
Yeah, well, again, it's worth going to the website. They talk about all these engineering challenges. A grain of dust like that makes up the asteroid Bennu is really bad news if you hit it at 1/10 the speed of light. So they have to, they have to consider what the risks are. And I think the first part of the journey is the trickiest bit, because there's a lot more matter around the sun than there is in the interstellar. But I can guess in the interstellar medium that there's going to be some stuff there, isn't there? Because it's the stuff gets thrown off by supernovae and so on. So it's an engineering problem. My guess is they won't just launch one. Once you put your laser up there, you might as well just launch one and then launch another one and then launch another one. Just keep on doing them. And again, my guess is the first one that gets launched will not be the first to arrive at Proxima Centauri. Either it'll get destroyed along the way because we haven't understood the risks well enough, or we'll have figured out how to do it better, so it'll be overtaken en route by the second or the third or the fourth one to be launched.
My understanding is indeed a train of these things would be sent up, because they have to be so light that there's no way you could put a transmitter powerful enough to reach Earth. So you have to daisy chain the transmission to get any information back.
Yes, and that makes things, because if one of them, well, I guess you'd build redundancy in that you can skip one or two of them, and I mean, obviously you've got to have the sponsor logos as well, so that's going to take up some of your space. But I mean, again, all this is engineering, which makes it all the more fun. Is that people like us, maybe not me, but people like us are going to make it happen. If it does happen, it's going to be the engineers who get the darn things there.
Well, and that's a fantastic point to leave it on for an Institution of Engineering and Technology webinar. Big up to the engineers. Thank you to everybody who's joined us. Thank you for all your wonderful questions. That's all we've got time for tonight. Thanks again to Mike for being such a fantastic speaker, and hope we can do it again sometime.
More where that came from. Thank you.
Take care. Bye.
Cheers.